Hello students, welcome back. So now we are going to be performing feature engineering on the MPG dataset. So the first thing I'm doing, importing pandas, SPD, I'm also importing my visualization library. So read my CSV file and I print some few 10 sample values just to see how my data looks like. So I print few sample values. Then I also print out df.describe. That gives me the important statistics on your data set. So you have miles per gallon, you have count, mean, standard deviation, minimum 25%, 25 percentile, sorry, 50 percentile, 75 percentile, maximum value. It gives me all this for each one of these columns. Uh, so let's start with the derived feature first. So let's say I want to derive some feature power to weight ratio. So instead of raw horsepower and weight, maybe I want to combine them. So you can do that. So in this case, I'm creating a new column called power to weight that would be divide horsepower by weight. And that creates my column. So in this case, when I run this, it gives me these columns right here: horsepower, weight, and power to weight ratio. And after this, we can drop our horsepower and weight column if we don't need that. And now let's do weight categories binning. In this case, my weight, it ranges from 1613 to 5140. This is my rate on my range of weight. So I'm creating three bins: light bins, medium bins, and heavy bins. The light would be from 0 to 2000, medium would be from 2000 to 3000, and the heavy would be from 3000 to 5200. So these are my weight bins: 0 to 2000, 2000 to 3000, and 3000 to 5200. And these are my weight labels right here. So in this case, I'm calling pandas cut inbuilt method supply your weight column, supply your bins. These are my bins right here. Also supply your labels right here. That would be this right here. And then after it prints out, it actually creates this weight category. I print out this data frame. In this case, I'm just printing only two columns: weight and weight category. So you can see that this particular weight has been assigned to medium. This one has been assigned to light, and likewise rest of them. Maybe you want to check the distribution. You want to see how many values are there inside each weight category. So you can do weight category value count. In this case, medium has 186, heavy there are 168 records, and light there are 44. So you have a lot of data that a lot of data for weight category that falls under medium. Uh, you can also display the mean miles per gallon by weight category. So in this case, I'm grouping by weight category, and I'm saying MPG. Grab the MPG and grabbing the mean of the MPG column. So in this case, you can see that for light, your weight category, your MPG is 33. For medium, it is 27, and for heavy, it is 16. So the observation is that your MPG, it decreases as we go from light to heavy. And by the way, binning over here, it reveals this trend a lot clearly. Step four, maybe you want to perform some visualization. So in this case, I'm using box plot. I'm giving my data frame df, and my x would be my weight category, the one I just created, the column I just created. My y would be your miles per gallon, and the order I want is in this order: light, medium, and heavy. So I plot this, and you can see that it goes light, medium, and heavy. Then this is the plot right here. And let me decrease the size of the screen. Okay. So you can see that there are some outliers for the medium. These are the outlier values. For the light, your miles per gallon is very high. It's kind of like a little bit higher. And your heavy weight category, your miles per gallon is low. Although there are some outlier values over here. And now let's create horsepower bin. In this case, I will be using quantile based binning. What it means is that I'll be using equal frequency bin. And the reason is because equal frequency bin, they're often better than your fixed bins. So in this case, I'm calling this Q cut. This is how you do quantile based binning. And what quantile basically means is going to give you equal number, pretty much it's going to try to put equal number of data points in your low, medium, and high. So it's going to allocate each number of data points to each one of the bins in equal proportion. So in this case, this is the column I'm using, and I'm specifying three bins. That hey, this time do three bins for low, medium, and high. These are my labels. And this particular command does that. Then I print out the first 10 samples, and you can see that your horsepower, which is 139, it comes in the high bin. Your horsepower 158, it comes under high. Your 1110 horsepower comes under medium. Let's check the value count for each one of them. So in this case, I'm doing horsepower bin value count, and you can see that, look at the count, it's pretty much equal now. So this is 144, low is 132, and medium is 116. It's not exactly same, but they are pretty much same proportion. If I want to display the average MPG by horsepower bin, I can do that too. So in this case, I'm doing df group by horsepower bin, And for miles per gallon, I want the mean value. So for the low horsepower means your miles per gallon is 31.1. For the medium horsepower, your miles per gallon is 22. And so you can see that for the low horsepower, you have a really high your high miles per gallon average. On the other hand, for the high horsepower, you have almost half of that miles per gallon mean average. We can also look at this data using box plot. So in this case, I'm using box plot. My X is horsepower bane and my Y is miles per gallon. And the order I want to display my data is in low, medium, and high. So when I do the box plot, you can see this. Let me decrease the size again. All right. So you can see that your horsepower bin, when it's low, your miles per gallon is a little bit higher. You can see that. And look at this. When your horsepower is is in a high range, which is over here, your miles per gallon is very low. So clearly, high horsepower gives you a better miles per gallon in your car. And let's create another column called age of car. This is basically a temporal feature. So what I'm doing, I'm checking the model year. I'm getting the maximum value of the model year, and I'm subtracting that from the model year. And this way, that'll give me my car age. So then after that, I print out these the value. Okay, so let me just increase. Oh, let me just decrease a little bit. Okay, so now when I print out this model year and car age, you can see that your the car that was made in 76, the age is 6. The car that was made in 82, the age is 0, because this one is my reference point right here. So I'm comparing every year the age with this 82. So 80 is 2 years old. 76, that will be 6 years old compared with this 82. Okay, and then at the end, I'm also printing all the some of the 10 samples. I want to print all the columns, and you can see that you have car age over here. You have horsepower bin, category bin. You know, all the columns that we just created. It's everything is in there. You can drop some of the columns that you don't need. You can use some of the columns depending on your further analysis.